When we did the two-stage to orbit analysis, we came up with these expressions here. What I want to do in this video is take a little closer look at some of the results that we get out of this comparison between the single stage to orbit and the two-stage to orbit launch vehicles. So let's just summarize some of the results that we've got. So we've got the mass of our payload in each case is 5,000 kilograms. For the single stage to orbit, so SSTO, the mass of the payload over the initial mass we found to be 0.02. And for our two-stage to orbit, we found the mass of the payload to the initial mass of stage 1 was 0.052. We also found for the two-stage to orbit that M02 over M01, the mass of the second stage to the mass of the first stage, was 0.227. Let me just slide the screen down a little bit, and I'm going to put a line down the middle of the screen. And on the left hand side we'll look at the single stage to orbit. On the right hand side we'll look at the two-stage to orbit. And for the single stage to orbit we had the mass of the payload over the initial takeoff mass being our 0.02. As we saw, that gave us a way to calculate the initial mass, which was our payload of 5,000 over this ratio 0.02. So that gave us 250,000 kilograms. Let's now look at the takeoff mass for our two-stage to orbit launch vehicle. So we have the mass of the payload over the initial takeoff mass being our 0.052. So therefore that gives us that our initial takeoff mass is equal to our payload 5,000 over 0.052. That comes out to be about 96,000 kilograms. Let's just round that up to 100,000. So we see immediately a much lower mass required at takeoff for our two-stage to orbit than for our single stage to orbit. Let's look at our structural masses. So for our single stage to orbit we had that was 7% of the initial takeoff mass, which gave us that the structural mass was 17,500 kilograms for our single stage to orbit launch vehicle. Now, a little bit more detailed analysis needed for the two-stage to orbit. We have the mass of our structure is now the mass of the structure for stage 1 plus the mass of the structure for stage 2. And for stage 1 we have 7% of our initial takeoff mass will be our structural mass for stage 1. So with 100,000 kilograms as our initial mass, that gives us 7,000 kilograms as being the mass of the structure for stage 1. For stage 2, the mass of the structure for stage 2 is going to be 7% of the initial mass of stage 2. And we can write this as 0.07 times M02 over M01 times M01. And we know from up here that M02 over M01 is 0.227. So this gives us 0.07 times 0.227 times our 100,000 kilograms. Slide the screen down a little bit. And that gives us a structural mass fraction for stage 2 of about 1,600 kilograms. Therefore, our overall structural mass is the sum of the structure for stage 1 and stage 2. So our 7,001 plus our 1,600 gives us about 8,600 kilograms. I'll just slide the screen down a little more, and the last thing I want to just look at is what's the total propellant mass that we've got. So for our single stage to orbit, the propellant mass was the initial mass minus the payload mass minus our structural mass, and when we put those numbers in, 250,000 minus 5,000 minus 17,500, and that gives us that number of 227,500 kilograms. Let's look at our two-stage to orbit vehicle, and the mass of the propellant is the initial mass minus the mass of the payload minus the mass of the structure for stage 1 minus the mass of the structure for stage 2. And when we put those numbers together, we end up with a number of 86,400 kilograms. So that's the total propellant from stages 1 and 2, but what we see is that that's much less than the 227,000 kilograms that we needed for the single stage to orbit vehicle. So in order to launch this payload, you can see that right across the board, in terms of the structural mass, in terms of the propellant mass, we get, and in terms of the initial takeoff mass, we get a much lower masses required for the two-stage to orbit than for the single stage to orbit.